All right, so for notes number 10, this is a continuation of exponential model. So this is part 2, and it's on compound interest. And this is an exponential model because compound interest goes up really quick and has a curve to it. So you can put numbers in here and test it out. Continuously compound is where you can really see it, and that's on the back side here. So let's get started because this is a longer set of notes. This is the formula for compound interest. So A is equal to P times 1 plus R over N, parentheses, to the Tn power. Those are multiplied up on top. A is your account balance with interest. So after you calculate everything out, that's how much you're paying with interest. Or how much is in your account with interest. P is your principal amount, so what you're putting in. So it could be like a $300 loan, or it could be I'm investing $300. So either way, rather you're investing or taking a loan out. This works both ways. R is your rate. They usually always give it to you as a percent, and you need to write it as a decimal. So if it's 5%, you would move it the decimal place over 2 times, so it would be 0.05. Okay, and then N is your number of times compounded per year. So it should tell you in an example compounded daily or compounded quarterly or compounded a certain amount. And basically all that means is they take interest that many times per year. So if they say quarterly, each quarter they're going to do the equation and then add interest. And then they're going to do that again the next quarter. So that would be your N value. So the N value is here and here. You have 2 spots for the N value. And then your time is in years. So they give you it in months. You need to transfer it into years. Whatever they put it in, it needs to be in years. Okay, so that's our formula. So let's do an example based off of the formula. I'm going to get some highlighters. Let me see. Okay. I think I'll do these based off of the color. So A, P, R, N, and T. Okay, so determine the account balance if you deposit $4,000 at an interest rate of 3.4% compounded semi-annually for 3 years and 6 months. Also find how much interest accumulated. So we need to do, this is 2 parts basically, but we are finding our account balance. So that's what we need to find. Our principal amount. So if you deposited 4,000, so that's what they're putting in. That's their beginning amount. Our interest rate is 3.4, which we need to make a decimal. And then our time is semi-annually. Semi-annually is 2, so they're going to compound it twice. And then our time is 3 years and 6 months. So we do need to make that into years. Okay, so when we're doing the formula, A is what we're looking for, and then P, so our P is 4,000, and then 1 plus our rate, which was 3.14. If we take 3.4, and we move it over twice, right here, we need to put another 0 there, so it's going to be 0.034 as our rate. Our N is semi-annually, which was 2. And then we need to do the TN there. So our time is 3 years and 6 months. 3 years and 6 months would be 3.5 years because 6 months is half of a year. And then times our N, which was 2. So times 2. Okay, you are definitely going to want to use a calculator for this. Let me grab one real fast. You're not going to want to do this in your head. So you can type it all the way in as long as you're doing it correctly. So 4,001 plus, is that going to work? It's not going to work. Dang it. With math. Aha, there we go. 0, 3, 4, 2 on the bottom, parentheses, and then to get up at the top, you press the caret, and then that's 3.5 times 2. So I was able to write everything at the same time and then equals. So our account balance is 4,598. We'll round to the cents because that makes more sense. Okay, so after 3.5 years, our account is going to be at 4,500 basically. Now to find, that's your account balance. To find your interest, which was the second part, interest, you're going to subtract our account balance minus our principal basically. So 4,598 cents minus the 4,000, right? So minus 4,000, you get 598 cents. There we go. Okay, so that is your interest. All right, so backside, I'm going to talk about continuously compound. That is when it keeps compounding over and over and over again. APRT stands for the same stuff. E is like E on your calculator. Where is it? E is right there in the green. So you guys are going to just leave E there, basically. So an investor put 12,600 into his bank. So A is equal to, there's our principal amount. So 12,600. E is always E, don't change it. And then R, that earns 3.2%. So 3.2, move that over 1, 2. So that's our new decimal spot and make a 0 there. So this is going to be 0.032. Compounded continuously, what is the account balance after 12 years? So times 12. Now, you know the difference between compound interest and continuously compound because of this word right here, compounded continuously. It has to say compounded continuously to use this formula, okay? And you can't do this in your head. You have to use a calculator for this. So 12,600, excuse me. And then to get the E, you do second, and then the LN, which gives you E. And then 0.032 times 12. So this is going to give us 18,498 and 63 cents. Okay, so this is awesome because if you're actually investing, this is a good difference. You know, it's just about $6,000. But it is over 12 years, so keep that in mind. But this is how you would do continuously compound interest. So again, it has to say compounded continuously to use this formula. Everything means the same. So the A is account balance, P is principal, R is rate, T is time in years. All that's the same. E is just always E. So you're always going to click E. There's nothing special to do there. Okay, so you'll use this formula when it is compounded continuously. If it is compounded something, like it tells you one of these things, then you'll be using our regular compound interest formula.